have Unit 3, Lesson 1. We're going to talk about just prime factors. It's kind of a basic number principle that we're going to kind of go through, and you'll end up kind of using it without knowing when you're getting through your math career in terms of factoring. You'll need to know the greatest common factor. Least common multiples will come up time to time. But just knowing what your prime factors are is important in terms of breaking numbers down. So, for example, just in general, what does a factor mean? A factor is when you have, like, for example, 6 has the number 1, 2, 3, and 6 all multiply to get 6. You have 1 times 6, 2 times 3, and then the reverse of each. So you have 4 factors of 6. Okay? So that's just kind of a breakdown what the factors are. And you'll state the factors of 15. So for 15, 1 and 15. You have 3 and 5. And that's it. So you have 4 factors for 15. 24's got a bunch. Okay? 1 times 24. 2 times 12. 3 times 8. 4 times 6. Okay? So you have 2, 4, 6 as 8 factors. Okay, and let's look at this next example here. Just kind of getting used to factors and multiples. So in each case, determine the number of factors of the given whole number. So the same thing. How many what factors? Well, factors of 3, it's a prime, so 1 and 3. We're going to get to that in a second. 10, 10 and 1, 5 and 2. Has 4. Okay, so it has 2. This one has 4. Okay, and then 1 has just itself, 1 times 1. 7, 1 times 7 has 2. 18 has 1 times 18. 2 times 9. 3 times 6, it has 6. Okay, so now it kind of leads us into prime and composite number. Prime number is defined as a whole number which has exactly 2 factors and are always 1 in the number itself. Example, 3 and 7. A composite number is a whole number which has more than 2 factors. Example, 10, 18. The number 1 has neither prime or composite, so it has only 1 factor. It's kind of unique. Okay, so these 2 are prime, these 2 are composite, and then this one is unique, the number 1, because it's just itself. Okay, let's get down here. We're going to complete the list of first 10 prime numbers. It's themselves and 1. So 2, 3, 5, we did 7. Let's see, 8, 9, 10, 11, 13, 17, 19, 23, 29, and that's where we're going to stop. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, that's the 10th. 29 is the 10th prime number. Okay. Move forward here. Okay, so classify the following as whole numbers. Classify the following as the whole numbers as prime or composite. So 46, as soon as I see a 6 being even, it's going to be composite. 37 is going to be prime. 39 is going to be composite because I know 13 goes into it 3 times. We have 101 actually is prime because it's just 101 in itself, and then 103 is also prime. Okay, the prime factors of a whole number are the factors of the number which are prime. For example, the factors of 6, 1, 2, 3, and 6, the prime numbers are 2 and 3. Okay, those are your prime factors. This is going to help us break numbers down. So going further here, so we have the example 4. So it asks us, so state the factors of 12, state the prime factors of 12, express 12 as a product of the prime factors. So we're going to go, okay, the factors of 12 are 1, 2, 3, 4, 6, 12. Okay, and so state the primes. So the primes would be 2, 3, and that's it. Okay, express 12 as a product of the prime factors. So you can only use 2's and 3's. So 2 times 2 is 4, times 3 is 12. So that is a prime factorization of 12. Okay. Now looking at prime factorization here, there's two ways you can use prime factorization. You can do a division table where you take the number and then continually divide down by prime numbers, or you can do a tree diagram. Tree diagram takes a little more space, but I kind of like it better in terms of the visual. You're welcome to use either one. I'll probably use the table most of the time for the examples. And so both these division table and tree diagram are breaking down 48 to its prime factor. So when you look at it, 2 times 2 times 2 times 2 times 3 is going to be 48. 2 times 4 times 2 is 8, times 2 is 16, times 3 is 48. Over here you have the same thing. It ends up being 2, 3, 2, 2, and 2 at the end of the tree. Kind of your last limbs are your prime factors. Okay. All right, just got a couple more here, and then it'll be it. Okay, so use division table. So it wants to use division table, so we'll go ahead and use one just for practice here to do 2, 7, 7, 2. So 2, 7, 7, 2. Okay, so we're kind of draw a line here, and we're going to first divide that by 2. That's going to give us 1386, and then we're going to divide that by 2, because I mean anytime you have even, and 2 is a prime number, so that's very helpful. 1386, that's 693. We're going to divide that by 3. That's going to give us 231. Divide that by 3, 77. And then we're going to divide that by 7, which is 11, and then 11, and you get to 1. Once you get to 1, that's the end. So here's your factors. Right here on your left column is your prime factors of 2, 7, 7, 2. So it would be 2 times 2 times, 3. Times 3 times 7 times 11. Okay, so that would give us ultimately 2772. Put that in your calculator. All right, in our last example, we're going to try a tree diagram. Okay, use a tree diagram to determine the prime factorization of 33,250. All right, so try to draw up top here so I have some room. So it's what you break it down to. So for example, I'm breaking this down to 10, and you can break it down any way you want. So you don't have to use 10. You could have used 50 if you wanted. Okay, but I went with 10. So 3325 times 10, and then the 10 breaks down to 5 and 2, and those are prime factors. So we're just going to leave those there. Those are end of the limbs. And look over here. I'm going to go 5 times 665, and then we're going to go 5 again times 133, and then 133 breaks down to 7 and 19. And all of these numbers here are into my limbs of my tree. Those are the numbers if you multiplied. Okay, if you multiplied them, you would get 33,250. Okay, so that's just the two basic ways of breaking numbers down into prime factorizations. Okay, so our prime factors again for 33,250 was 5, 2, 5, 5, 7, 19. So it had 6 numbers. All right, and that is it for prime factoring.